All right, so I'm going to tell you guys a bit of a story about an incident that happened at Wave not that long ago. It's an opportunity for us to share some of the realities of being in a fast-growing startup and some of the decisions that you have to make. But even if you run out of integers, things aren't that bad. So it was a normal Friday, probably 2 or 3 months ago. I was kind of in my morning routine, getting dressed, and my phone starts buzzing a bunch, but I'm not on call. So I was like, this can't be so bad. So I opened up Slack, and a bunch of people are talking about, hey, there's all this weird behavior on the site, and it's easily reproducible. So I just kind of stop what I'm doing, grab my laptop, sit at my desk at home, start pulling up error logs, and along with some other people in the moment, we start seeing this number. 4,294,000,000, something, something, something. Took us a few minutes, and then eventually someone took that number, put it into Google, and linked this picture, and it turns out that's the maximum unsigned integer value in MySQL. And I already knew at that point I was going to have a very long day. So I'm Alex. I'm a staff engineer here at Wave. I've been at Wave for about 5 years. I'm also the organizer of the Python meetup, so if you're interested in Python, you can come talk to me. And tonight I want to kind of set some ground rules. This is, in the most traditional sense, going to be a retrospective. So we run retrospectives regularly at Wave, and we always recite what's called the retrospective prime directive. So regardless of what we discover, we understand and truly believe that everyone did the best job they could, given what they knew at the time, their skills and abilities, the resources available, and the situation at hand. It's all about learning and no blame, and when we make decisions in the moment, it's often because we need to make a decision, and the cost of not making a decision, even if it's the wrong one, far outweighs not making one. So, how did we get to running out of integers? Here is a sample schema in which you will run out of integers. Can anyone spot the problem? Yes. Okay. So log ID is an integer, not a foreign key. That's weird. Okay, let's find out why at Wave we have that situation. What's this graph?
User growth.
This is, if you took this graph to any VC, they would keep giving you more money, right? Unless you realize that it's actually this graph, and you're going to run out of disk space in a few months. This is the situation that Wave was in. We kind of projected, maybe we had a year left of disk space, we couldn't buy a bigger one. So I think with this is kind of going back to 2011, 2012, we were probably in a situation like this. So I'll tell you right now, we did not choose MongoDB, we did not go NoSQL, we did not kind of get all this magical clustering and sharding stuff. We kind of bucked the trend in that moment because SQL, the semantics of SQL, were very important to us. So people understood ACID, people understood database transactions, all the things that were very much not available in any NoSQL solution at the time. So we kind of went down the path of reinventing the wheel and sharding SQL. Most people don't know what sharding SQL is. It's not something that a lot of companies have to do. We were kind of in a situation where data growth was explosive. We're a free product. We have, today, we have 80,000 signups a month. Back then, it was probably 20,000, but it was still like outrageous. So we had a architecture that looked kind of like everyone else's. You had a load balancer and web servers in one giant database, and you can keep adding more web servers, but you cannot add more databases in this. You're just stuck. So when you shard SQL, you have to choose your partitioning strategy. How are you going to split your data across your databases? So there's kind of two main ones you can go after. One should look very familiar to people in the startup world today, is that you take each of your tables and you put them on their own databases. This is microservices. If you do microservices today, this is what you do. And if you go back to my sample schema, this is the situation you start ending up in, is that you can no longer use foreign keys to actually link the data between your tables. There's a pretty big flaw in this though, which is maybe you've distributed the tables across different databases, but let's say the comments database kept growing at an exponential rate. Eventually you'll run out of data on that database too. So you can also do another strategy, which is partitioning by user. So you have all the same tables, copies of the same tables on each DB, and then you kind of say user 1, 2, 3, 4, they're going on the first DB, 4, 5, 6, on the second DB, 7, 8, 9, on the third DB. And it's actually really convenient as a developer because all you do is look up which database you have to connect to, and then it's all kind of normal life. You're not trying to connect to multiple DBs and do joins. And here's where we made a mistake. We kind of did both. And we ended up with the great scalability. We can keep, we got many database nodes, but we lose that kind of the relationalness, the transactional nature. We cannot use the built-in semantics of SQL to protect us from doing bad things. So, we're in this situation. We have a table that its primary keys that it's generating are now bigger than the integer space itself. But there is actually a solution, which is the integer field is not the biggest integer field. It is actually called the big integer field. And all we had to do was do a schema migration on all of our databases from integer to big integer. And it turned out that this is actually not even a code change for us because we're a Django shop. And Django actually doesn't care if it's an integer or a big integer. It relies on SQL to do that validation. Now, what's the problem here? If you kind of look at this and you start doing some math in your head, how many tables do you think we'd have to do schema migrations on? And these are all like really hot tables, and we can't take downtime, and we're on MySQL, so like online migrations are really hard. And I got the update from Craig today. You had to migrate 72 separate databases to kind of get out of the weeds on this. And at the time, that was estimated to be 1 week of constant 24-hour migrations. These things aren't like set it and forget it. They actually take some babysitting. And because if it blows up, we might lose 9 hours of a migration. So we needed plan B. Like, we have the long-term strategy, but the site is effectively down. What are we going to do? So we gathered a bunch of people. I was still at home, kind of barely dressed, sitting in front of my computer, and then kind of like 9 other people were in a room over there. And we started kind of banging out some ideas about how to get the site back online as fast as possible, as safely as possible. So what happens when you take a bunch of really smart people? Well, they come up with like the really hard idea, which is, okay, if we add one new column in the database, we treat that as like an offset. We can then get like another 4 billion integers, right? So we actually spend probably like 2 or 3 hours like writing the code to go and do this on every single model that was affected by this. And then we realized it was like impossible to test because try simulating running out of integers on your laptop. Not really sustainable. It was going to be extremely hard to test. Luckily, there's another solution. When you are so crazy that you go and make this decision a long time ago, we made another interesting decision. So when you're sharding databases, another thing that's a common technique is to use what are called globally unique IDs across your databases. And this means that down the road, if you had to move someone's data from one shard to another, that the IDs couldn't collide. Or if you are moving that data from your online database to like into Redshift for some data analytics stuff, the IDs are all unique. So that meant that on any given table, it actually didn't use up the entire integer space. So we had a bunch of unused keys that if we could find a way to utilize them, then we could kind of get out of this situation. So we had some crazy ideas like, okay, once if we use our BI system to find out all the unused keys by shard, put those in Redis, update our key generation strategy, start popping keys off those lists, and that would work. So we tried writing a really rudimentary version of that for probably about half an hour. But then we realized there was a much stupider solution. Could we just use rand int in a few retries? The queue space was it's 4 billion. It's really big. And less than half of the keys are used at any given table. So chances are, within 1 or 2 retries, you're going to get a valid ID. So we implemented that in 10 minutes and rolled it out for production, and that was it. So for about a week, actually maybe a bit longer, our key generation strategy was just rand int. Luckily, our ops team was very good and pulled shift work to actually go and keep running all those migrations, and we were able to successfully, not the first time, actually go and turn off the rand int generation. There's also some kind of weird stuff, like we had a whole bunch of records that now have IDs that are too big, so we had to go and write a script that went and found all the records that were too big and actually resaved them with the new rand int. We got the site back online, it took about 20 hours, but most of our users didn't actually notice, but there are some people who got some extra time off for sure. The moral of the story is we're all going to make mistakes. And you're going to make a decision at your startup that you will regret later. And what really matters is how you recover from it. And make sure that you learn from those mistakes and move forward. That's it.
Yeah, I'm curious, like, if anything went wrong throughout this whole process, did you have kind of like a larger rollback strategy or anything like that? Or?
No, I don't know how I would have one.
That's okay.
One of the first things that we did was actually turn off the most affected part of the site. So there was one feature that was like really, really, really broken.
Okay.
So we were able to go and like literally like comment out the HTML template like really fast and be like, please don't use this. Beyond that, it wasn't any kind of data issues that we weren't equipped to fix. Also, you don't run that really weird, crazy thing and not have previous data issues. So we're pros.
Go back to the point where we're making that initial implementation decision. Is there another direction that you would have taken that would have prevented this issue?
Right. So I guess, would you choose option A, B, or C? Well, definitely not C. No one ever implements C. If your boss says implement C, I'll come and talk to them. There's like physical scars on my body. I would say implement B, partition by user. It is by far the easiest thing you can do. This is how everything, other than this one system that way that's like this, is implemented this way.
So when you say partition by user, do you mean like logical rows of users, like by geography or something like that, or?
It's a little steeper than that.
Okay.
So when you sign up for Wave, we actually kind of round robin assign you to a database.
Oh, okay.
Then we have a table that tracks which database you're in.
How's that strategy work with practice? Are you running analysis support, or is it
So that does generally work because there's just so many people. If you have a low traffic site, like Wave, again, saying we have 80,000 signups a month, so we have a lot of users signing up. If you have a lower traffic site, you will see hotspots kind of emerge on your shards. You'll have whales kind of accidentally build up on one shard. At that point, you might want to choose a different strategy if you don't have the volume, but I don't know what exactly you would choose. Other than prepare to actively move people from one database to another, which is a very big pain. Any other questions? Okay, if you're just too shy, you can come talk to me after. And thank you. Yeah.